Next, we're going to enter some data from the book and save it as a vector in R called x. So the data is from a random sample of the height of US women, and it is found on page 9 of the text. So in R we can type capital X with the less than sign and a dash, and lowercase c, which stands for combine or concatenate. We're going to combine the following numbers into one vector in R. So the numbers are 61, 63.5, 66, 68.5, and 71. And in R, you can see your workspace image by typing ls, open paren, close paren. And in the workspace image, what you're seeing here is that R has one piece of data, this vector called x. As an aside, you can note that the workspace image is typically under default conditions saved in the working directory that you exit R in. So keep that in mind if you're going to change working directories during your session. So R knows that there's something called x here. If you type x, you get those numbers back, and we can use R to manipulate these numbers. So the textbook states that the mean of these data is known to be 66 inches with a known standard deviation of 2.5 inches. So let's use R to calculate the standardized z values from this data. So z is equal to x minus the mean of 66 divided by the standard deviation of 2.5. And if you type in z, you'll see the results of the standardized z-scores there. You can also use R to calculate the mean. So mean of x, the variance as VAR of x, and the standard deviation SD of x. Now, let's assume that the heights are distributed according to the normal distribution with that mean of 66 inches and standard deviation of 2.5. We can have R randomly sample from this distribution. So let's create a sample of 100 draws. We're going to call it x100, and we're going to use the command rnorm to give us 100 draws from that random distribution with a mean of 66 and a standard deviation of 2.5. So what this is telling R is grab 100 numbers from a random normal distribution that it creates with a mean of 66 and a standard deviation of 2.5. Technically it's pseudo-random because R will actually use the current date and time when you do this to seed the random number generator. So if your numbers are different here than what show up in the text, no need to worry, and we'll talk about that again soon. So we can find the mean of this draw. We can find the standard deviation of this draw. And we can have R create a simple histogram for what these data look like. HIST x100, and R will open up the histogram there in the window. And so now we're going to seed the random normal distribution so that we can get the same results. This is helpful if you're trying to do something that is completely reproducible. So we say set seed set.seed of 100. That's the seed value, and we're going to define a new draw as x100a, once again with rnorm, and it's going to be a draw of 100, and the distribution it's pulling from has a mean of 66 and a standard deviation equal to 2.5. And once again, we can find the mean of this. And your mean should match that, as well as the standard deviation of this draw. And once again, your standard deviation should match that. And now we'll create a histogram of this draw as such. And we can determine the quantiles of the data using the quantile command. Which will show you by default quantiles at the standard probabilities of 0%, 25%, 50%, 75%, and 100%. So in this case, we can see that the median of this random sample is 65.85. So now we're going to go ahead and look at the distribution of a draw from a much larger sample of size 20,000, again from a standard normal distribution. So let's set a new seed, set.seed 666, and we're going to call this draw zdraw. And in the rnorm command, we're going to ask for a draw of size 20,000. And we're going to give it a new mean and a standard deviation of 1. And so now we can find the mean of zdraw, which should be the same. You should have the same as what I have here, 0.007248. And so now we're going to once again grab the quantiles, but we're going to request certain percentiles for the probabilities. So we're going to say quantile of zdraw, and for the probabilities, once again we're going to use that combine function of 0.01, 0.05, 0.95, and 0.99. Make sure you close that off. And here R will return the requested percentiles. And next we're going to do a density plot of the large draw. So we're going to say plot density zdraw. And here we have simply demonstrated using the setSeed command and some essential basic functions.